OpenRouter says a budget panel beat Solo GPT 5.5 and Claude Opus 4.8 on a deep research benchmark. That sounds like a coding superpower. It is not. This is fluid coding and AI, and today we are testing whether Fusion is actually useful for developer decisions. The question is not whether Fusion can write code better than every single model. OpenRouter explicitly frames it as multi-model deliberation for prompts worth extra time and money, so the developer test is different. Can Fusion help with architecture decisions, upgrade risk, code review planning, incident analysis, and documentation research, or does it create one more polished answer that someone still has to audit? Fusion starts with an outer model. That model can decide to call the Fusion tool, or you can force the call when the task deserves deliberation. Fusion then sends the prompt to a panel of models in parallel. Each panel model can use web search and web fetch. A judge model compares the responses, looks for consensus and contradictions, and gives structured analysis back to the outer model. OpenRouter exposes this idea in several ways. The simplest path is the OpenRouter Fusion model alias, which auto-injects the Fusion tool. The server tool path gives more control over the outer model and configuration. There is also a plugin path and a Fusion chatroom-style interface. Under the hood, the important pattern is the same: multiple model answers, a judge comparison, then a final response written from that analysis. The headline claim comes from OpenRouter's June 2026 launch post. On 100 DRACO deep research tasks, OpenRouter reports that a budget Fusion panel using Gemini 3 Flash, Kimi K2.6, and DeepSeek V4 Pro, synthesized by Claude Opus 4.8, scored 64.8, and Solo GPT 5.4.8, and Solo Claude Opus 4.8, and came within 1 point of Claude Fable 5 at about half Fable's cost. That is interesting evidence, but it is not proof that Fusion is a better coding agent. OpenRouter calls DRACO a deep research benchmark, not a long-horizon software engineering test. The results are also first-party. OpenRouter says it used the same search, fetch, and bash tools for solo models and panels, and it blocked rubric hosting domains after finding a contamination risk. Useful, yes. Universal proof, no. DRACO is not a trivia quiz. It stands for Deep Research Accuracy, Completeness, and Objectivity. Perplexity describes it as 100 complex research tasks sampled from real user requests, spanning domains like law, medicine, finance, technology, shopping, UX, and general knowledge. The tasks are graded with expert rubrics, citation quality matters, and bad unsupported claims can be penalized. That makes it relevant to developer research even if it is not coding. The trade-off is immediate. OpenRouter's docs say Fusion runs n panel calls plus 1 judge call, on top of the normal request. With the default 3-model panel, developers should expect roughly 4 to 5 times the cost of a single completion on the same prompt. The launch FAQ says a Fusion call is often 2 to 3 times slower than a standard call. That is fine for a high-stakes decision. It is terrible for autocomplete. The most valuable Fusion output may not be the final answer. It may be the disagreement. OpenRouter says the judge analysis is meant to surface consensus, contradictions, partial coverage, unique insights, and blind spots. The server tool docs also matter because they describe returning raw panel responses and failed model metadata. If your team cannot inspect the sources, failures, and contradictions, the polished synthesis can become another opaque layer. The first strong use case is an architecture decision record. Imagine a team deciding whether order state should stay in Postgres row locks or move toward an event-sourced workflow. A single model may give a clean recommendation too quickly. Fusion is useful if the panel exposes migration risk, data consistency trade-offs, observability gaps, and what evidence would change the recommendation. The win is not certainty. The win is a better decision brief. The second use case is dependency upgrade risk. Major framework upgrades hide risk across release notes, migration guides, security advisories, GitHub issues, and plugin compatibility. Fusion may help because one model might catch breaking API changes, another might find security notes, and another might notice ecosystem incompatibilities. but the output only earns trust if it separates confirmed breaks from plausible risks, and if the version numbers and dates trace back to real sources. For code review, Fusion should not pretend to find bugs it cannot prove. A better prompt is a review plan. Given a diff summary, ask what reviewers should inspect first, what tests should exist, and what production failure modes are plausible. The panel is helpful when it gives competing interpretations of risk. It is harmful when it turns speculation into accusations. Reviewers need file paths, behaviors, test gaps, and reproduction ideas. Incident analysis and documentation research are where contradiction visibility can really matter. In an incident, Fusion should compare hypotheses against logs, metrics, deploy timing, configuration diffs, and user reports. It should make uncertainty visible, not invent a root cause. In documentation research, Fusion should compare official docs, migration guides, and SDK examples, then call out where examples conflict. The key question is always the same: did this reduce review work, or did it create another answer to verify? The fair comparison is not Fusion versus a weak baseline. It is Fusion versus one strong model with the same prompt and the same source access. Measure latency, total cost, source quality, contradiction visibility, failure metadata, and whether the answer made the human decision easier. If the fused answer is longer, smoother, and harder to audit, it lost. If it exposes a missed assumption before a team commits, it may be worth the spend. My practical verdict is simple. Use Fusion as an escalation policy. Keep a cheap or fast model for routine drafting, extraction, and low-risk chat. Use one strong model for hard implementation work. Bring in Fusion when the cost of missing a source, a contradiction, or a blind spot is higher than the extra latency and spend. The benchmark makes Fusion worth testing for developer research. It does not make it the default coding brain. If you test Fusion, judge it by the disagreements it surfaces, not just the answer it writes. Like the video if this helped, and subscribe to Fluid Coding and AI for more practical breakdowns of AI tools for developers.